This movie provides some comments to homework 3 problems. Let's say you have to calculate the net force and 3 individual forces acting on an object. Let's say 10 newtons, 15 newtons, 20 newtons. Let's call them F1, F2, F3. We also need to know the angles. So let's say 110 degrees, 100 degrees. So this one will be equal to 360 minus 100 minus 110, 150. Right. Well, the net force is equal to the sum of all forces. We just have to remember when we write it like that, we don't mean adding magnitudes. That is wrong. This is what we mean. Equals this arrow which points in given direction and 10 newtons long plus this arrow which points in a given direction 15 newton long plus this arrow. That's what it literally means. Now we know that every vector has 2 components relative to 2 axes, x, y. Well, the last one is the easiest one. So this arrow is perpendicular to the x-axis, so it doesn't have any x component to it. And the y component, well, it has to be negative because the arrow is opposite to the direction of the axis. So negative. And the magnitude of this component has to be equal to the magnitude of this arrow. So 20. Done. Now this arrow. It has 2 components. The x component points to the right, the y component. This is 10 F1. Points up. So as we know, a vector together with its components always form a right angle triangle. So the triangle, this triangle, looks like this. The hypotenuse equals 10 newtons, and we need to calculate these sides. The x component is positive, and points in the positive x direction. The y component is positive. So each component is positive. Now, if we need to relate the component and the hypotenuse, we need to know this angle. Well, so we have to go back to this picture and see the same angle here. So the component is horizontal. It's parallel to the x-axis. So we have to draw that x-axis, and this is the angle, the same as this. And this angle has to be equal to, well, the angle equal to 100 degrees minus this angle. The vertical direction is perpendicular to the horizontal direction. This angle equals 90 degrees. So this angle will be equal to 100 minus 90, 10 degrees. Now we can start using equations related to a right angle triangle. This is the right angle, hypotenuse. So this side is opposite to this angle. Opposite means use a sine. So it will be equal to 10 times sine of 10 degrees. This will be equal to the hypotenuse 10 newtons times cosine of 10 degrees. So F1y will be equal to 10 times sine of 10 degrees. You see degrees, we have to use degrees. And gives about 1.7 newtons. And the x component 10 times cosine of 10 degrees, about 9.8 newtons. Well, almost there. One more arrow. This number, force number 2. So again, this is the force number 2. Well, okay, let's use the blue marker. Little bit. Well, this arrow also has two components. The x component, F2x, points to the left, which makes it negative. The y component points up, which makes it positive. So again, vector together with components always form a right angle triangle. The hypotenuse equals 15. This side is equal to the magnitude of the x component. This side is equal to the component because it's positive. And now we can use a triangle. We need an angle. Well, which angle can we use? Well, for example, we can calculate this angle. This red line represents 180 degrees angle, and we have to subtract 10, and then we have to subtract 150. So 180 minus 160, 20. We gotta use geometry sometimes. So now F2y. This side is opposite to this angle. We have to use a sine, hypotenuse times sine of 20 degrees. And the magnitude of the x component will be equal to 15 times cosine of 20 degrees. So the y component will be equal to, well, 15 times the sine of 20, about 5.1. What about the x component? The x component has to be negative, so it will be equal to negative this number, negative 1 times this number. 15 times cosine of 20, about 14 newtons. Well, now the net force has two components as well. So to calculate the x component of the net force, we have to add the x component of each individual force. To calculate the y component of the net force, we have to add the y components also. This is negative 14. The force number 3 doesn't have the x component. The force number 1 has the x component equal to 9.8. And now plus plus, this equals 5.1. The force number 1, 1.7, and the force number 3 has the y component, which is negative 20. So now we're going to take calculator and calculate 9.8 minus 14, negative 4.2 newtons. And 1.5 plus 5.1 minus 20, negative 13.4 newtons. So it turns out our net force will be directed like this. So if we draw the x-axis and the y-axis, the net force, both components are negative 4.2, that's the x component of the net force, and negative 13.4. That's the y component of the net force. So the net force will be equal to, well, we have to add the components as vectors. This arrow represents the net force. And again, as we know, a vector together with components always form a right-angled triangle. So now we have to apply the Pythagorean theorem to calculate the magnitude of the net force. Equals square root of 4.2 squared plus 13.4 squared, and then gives us square root about 14 newtons, which is again not equal to 10 plus 15 plus 20. And the next possible situation is kind of opposite to this. The next possible situation let's say we know this force and the angles. Next possible situation is when we know the net force and we need to calculate the individual forces. So let's say this force equals 30 newtons and we have two forces and we actually don't know how long or how short should be those arrows because we don't know the magnitudes. We do know angles. Let's make same angles, 100 degrees here, 110 degrees here, and let's call them again F1, F2, the magnitude of these forces we are looking for. This is F3, and well, an additional condition is this object is in equilibrium, which means the net force has to be equal to 0. Which means again F1 plus F2 plus F3 equals to 0. But we can't add the numbers which represent magnitudes because that's never works. So that is wrong. What we know now is that if we add x components, we should have the x component of the net force, and since the whole force is 0, that has to be equal to 0. And if we add y components, that should be equal to the y component of the net force, and because the whole force is 0, the component also has to be equal to 0. So strictly speaking, these are the equations, two equations we will have to solve. Well, we know from the previous experience we're going to use some angles. So let's see those angles. First we have to draw two axes. The x-axis, the y-axis. Again, this angle will be equal to 100 minus 90, 10 degrees. And again, let's say this whole angle will be equal to 360 minus 100, 260 minus 110, 150 degrees. And again, this angle will be equal to 180 minus 10 and minus 150, 20 degrees. Now we can write two equations. Force number one has the x component which points to the right, and it has to be equal to the hypotenuse times cosine of 10 degrees, plus the force number two has a negative x component. It will be equal to, well, because it's negative, minus hypotenuse. Hypotenuse represents the magnitude of this force, times cosine of 20 degrees, plus this force doesn't have the x component, 0 equals 0. That's the equation number one. Now, equation number two. This force has a positive y component. It will be equal to the hypotenuse times the sine of 10 degrees, plus this force also has a positive y component, and it will be equal to the hypotenuse times the sine of 20 degrees, plus, now this force has a negative y component, negative 30, and if we add them up, that's going to be equal to 0. What we have here is two equations, but we also have only two unknowns, so it's solvable. How can we solve it? Well, let's refresh briefly some math. Well, first of all, let's rewrite it. F1 times cosine of 10 minus F2 times cosine of 20 equals 0, and here F1 times sine of 10 plus F2 times sine of 20 equals 30. Bring it over here. From this equation, F1 will be equal to, bring it over here, F2 times cosine of 20 divided by cosine of 10. And now we can use this expression to replace the magnitude of the force number one in the second equation. F2 cosine of 20 or cosine of 10 times sine of 10 plus F2 times sine of 20 equals 30. F2 is a common factor, so we can solve it for F2. That will be equal to (30) divided by cosine of 20 divided by cosine of 10 times sine of 10 plus sine of 20. Now it's, well, a matter of taking a calculator and finishing this calculation.